So in the previous video, we set up the machining coordinate system. What we're going to do now is we're going to move ahead to define the machine tool. Of course, the coordinate system is very important because the axes of the coordinate system have to be consistent with the axes of the CNC machine you're going to use. So again, if you recall, we get to the place where we can define this information by double-clicking on the setup. In this case, we're defining setup 1. And again, this is what we did in the previous video, the machining axis system. What we're going to do now is define the machine. So I'm going to click on the machine tool. And you can change the name of the machine. I'm going to just leave it as the default 3-axis machine.1. There are a number of tabs here, not all of which are that important. This first tab here shows the location of the home position of the machine with respect to the machining coordinate system. So you can see right now that the tool change point, which actually corresponds in most cases with the machine tool home position, is positioned at 3.937 inches above in the Z direction. Now this is the home position of the machine here. This coordinate system, I'm going to come out of this temporarily just to show you, cancel. And I'm going to cancel out of this. If we go over to the work envelope within the product list, you can see the axis systems here if you expand out. So this axis system is actually the axis system of the home, of the machine home, based upon the work envelope. So if I unhide this part body here, you can see the work envelope of the machine. So it might be helpful to establish the home position in our definition of the machine to be the correct offset from the machining coordinate system. So to do that, I'm going to go ahead and just simply measure the distance from the corner of the stock to the coordinate system that represents the machine home. So I'm going to go ahead and pick the point. Notice that if I move the mouse, the coordinate system highlights. To make sure I get the point, I have to hold on the alternate key and click with the tip of the finger over the corner. And if I go down, you'll see that there's something called a vertex, so that refers to the vertex. So I'm actually trying to pick something that is hidden behind something else. This is how you would do it. And then I'm going to go ahead and click on the ruler, the measure between. Actually, I lost my pick there, so I'm going to have to redo it again. And then here. So this here gives me the offset between the top of the corner of the part and the machine home. I'm going to use the screen grab tool, the snip tool, just to keep track of these numbers. So there they are, just so that I can type them in correctly. So now that I have the offset measured, I'm going to go back up to my setup. Double click on this. I'm going to go to my machine, and then I'm going to input these offset values. So the first one was 8.844, Y shift 4.463, and the Z shift 12.608. So now my home point with respect to my machining axis system has been established. Notice that the tool change point hasn't changed. I actually have to input the information again for the tool change point because the tool change point does not always have to be the same position as the machine home point. On the tooling tab, there's not much that needs to be done there. Under compensation, neither. On the numerical control, what we need to do here is we need to specify the post that's going to be used to convert the code, the toolpaths generated in CATIA, into the correct code for our Haas milling machines. So each milling machine is slightly different, and so these posts help to customize the output to match the machine. So I'm going to scroll down this list, and the post we're going to use is this one here, Haas modified 2019.lib. So I'm going to select that. And then to go with the post, there is a words table that is needed. And the one that we're going to use is the ims.pp table. So make sure that these two are set correctly. Those are the only two things that need to be set here for the time being. These are important when you start generating code to make sure that that code is correct. Actually, it might also be good to set the maximum machining feed rate. And my numbers might be a little bit off here, so at some point in time we may have to come back and change these, but this is kind of in the ballpark. 650 inches per minute and a rapid rate of 1,000 inches per minute. Okay, so let's hit OK here. So now we've defined our machine. So this is the second step in the process. The first step was to define the machining coordinate system. The next step is to define the machine.